Hi guys, in this video I'm going to talk about the 4 different types of linear equation. So just a reminder, linear equations are equations where if they're plotted onto a graph, we'll generate a straight line. So the first one is one you'll probably be very familiar with, slope-intercept form. This looks like y equals mx plus c, where m and c are constants. And the really nice thing about this form is that it's very easy to visualize because m represents the slope of the line and c represents the y-intercept. So that's where it intercepts the y-axis. Okay, so slope-intercept form is very easy to use. If we look at general form, that's a little bit trickier, but it has one advantage. The thing with general form is the x and the y are on the same side of the equation. So we have a, which is a constant, multiplied by x, plus b, which is a constant, multiplied by y, and that equals capital C. Now note that that is different to lowercase c, which is in slope-intercept form. Now with the general form of the equation, we can actually rearrange that so to get something that looks like slope-intercept form. So that'll actually tell us how to get the slope and the y-intercept from the general form of the equation. So what I'm going to do is I'm going to take the x part over to the other side. So that'll say by equals negative ax plus c. So I've subtracted ax from both sides. And then I'm going to divide both sides by b. And what we get is negative a over b multiplied by x plus c over b on the end. So all I've done there is I've moved from general form into slope-intercept form, and that tells us that this part here, the number in front of the x, just like in slope-intercept form, is telling us the slope, but we've taken it from the constants capital A and capital B. Now this number on the end is going to tell us the y-intercept. So if our equation's in general form, the y-intercept is capital C over capital B. Okay, so this is just 2 different ways of writing the same equation. The next one that we can look at is the horizontal line. So horizontal lines, they just have an equation that looks like y equals b, where b is a constant. So the reason for that, if we look at an axis, if you look at a horizontal line, let's say whatever this y-intercept here is b, every point on that line is going to have the same y-coordinate, which is b. Now there's 2 things to know about horizontal lines. The first one is that the slope equals 0. So there's 0 gradient because we're not going up or down if we move from left to right. The other thing to know about a horizontal line is that the y-intercept is just whatever the value is, which is lowercase b. Okay. And then finally we can look at a vertical line. This is kind of the opposite of a horizontal line. It's got an equation that looks like x equals a. So it might be something like this. It's on the x-axis at some point a, where a is a constant. Vertical lines are a bit odd because, number one thing, if you try and work out the slope of a vertical line, it's actually undefined. Because if you think about it, it's rise over run, and if you're on a vertical line, the run will always be 0. So if you remember, slope equals rise over run. If the bottom line of this is, I have to write it down here, is 0, you'll always get undefined if you try and calculate that. Another way of thinking about it is that the slope tells you how far across you go, how far up you go every time you go across, and you're not going across, so there's no way of working out the slope. With a vertical line as well, if we tried to work out the y-intercept, well, there is none. There's none at all. Okay, so hopefully that has helped explain the different types of linear equation. In the next few videos, we'll have a look at how to work with those.